Alright, so here's your homework. Practicing work, rate, and mixture problems together. Let's do it together. I hope that you do it first and then press play to see if you did it correctly. And if you need support, then you work with me. But your goal is to do it by yourself first. Working together, Dan and Julia can clean an attic in 5 hours. Had she done it alone, it would have taken Julia 15 hours. How long would it take Dan to do it alone? So Julia takes 15 hours, so her rate is 1 over 15. Dan is my unknown, so his rate is 1 over x. And then together, the rate would be 1 over 5. Make common denominators, so that's going to be 15x. So this is going to be x. This is going to be 15. And this is going to be 3x. So we have common denominators. So x times 1, 15. And 1 times 3x, then we're going to solve it. So subtract 1, so that's 2, divide, it's a nice easy decimal, 7.5. So how long would it take Dan to do it alone? It would take Dan 7.5 hours, yes, to do what? To clean the attic alone. Beautiful. Number 2. You should press pause and try it first. Brenda can mop a warehouse in 10 hours. One day her friend, Beth, helped her. It took 5 hours together. Find out how long it would take Beth to do it alone. So Brenda alone, that's her rate. Beth, I don't know, it's an unknown. But together, that's the rate. And then common denominators and solve it. So the common denominator is going to be 10x. So we multiply, make each denominator 10x by multiplying. Now that we have common denominators, x times 1, 1 times 10, and 1 times 2x. Subtract 1x, and you have your answer. It would take Beth 10 hours to do what? To mop a warehouse. Alone. Number 3. Again, press pause. You do it first. Working alone, Mofor can wax a floor in 14 minutes. One day his friend Adam helped him. It took 8 minutes working together. How long would it take Adam to do it alone? So the rate for Mofor is 1 over 14. I don't know about Adam, but together the rate would be 1 over 8. Common denominators. One way, let me show you something. One way to make common denominators, if you're confused, is to break it down into factors, a common factor. So 2 goes into both evenly, right? 2 goes into both evenly. So 14 is 2 times 7, and 8 is 2 times 4. It's easier to understand what to multiply to make the denominators the same when you break it down that way. We need to multiply this times 4 and an x, top and bottom. We need to multiply this times 7, top and bottom, and an x. And then 2 times 4 times 7 is 56, top and bottom. So that's one way to get common denominators. So just the numerators, and then solve it. So subtract 4, divide by 3, and it's about 19 when you divide by 3. 3 times 19 is 57, close enough. So how long would it take Adam to do it alone? It would take Adam 19 minutes to do what? To wax a floor by himself. Number 4, working alone, Lisa can pick 40 bushels of apples in 12 hours. Brenda can do the same in 8 hours. If they work together, how long would it take it? So Lisa's rate would be 1 over 12. Brenda's rate is 1 over 8. And then my unknown rate together. Common denominators, I'm going to do the same technique so that you can see it twice. So the number that goes into both evenly is 4. So 4 times 3, 4 times 2. So to make them the same, we need to multiply this by 2x. And we need to multiply this by 3x so that the bottoms can be the same. 4 times 2 times 3 is 24. And now you have common denominators. Just a different technique to get common denominators. The numerators we write down and then we solve it. When I divide by 5, the answer is pretty close to 5. Not quite. And so how long would it take for them if they work together? So working together, it would take about 5 hours to do what? To pick 40 bushels of, 40 bushels of apples. All right, turn the page. Couple more like this. Try number 5, then press play, press pause. Working alone, Wilbur can pick 40 bushels of apples in 12 hours. One day his friend Elisa helped him, and it only took 6. Working together, how long would it take Elisa working alone? So the first rate would be 1 over 12, my unknown rate, and then together rate. And then I solve it. So the common denominator is going to be 12x. So make common denominators and then solve it. So 1 times x, 1 times 12, 1 times 2x, subtract x, and you get 12. So it would take Elisa how many hours? 12 hours to pick, again, 40 bushels of apples alone. All right, number 6, working alone. You should press pause and try it, right? Then press play. Heather can mop a warehouse in 12 hours. One day, her friend Stefan helped her, and it only took 8. Find how long it would take Stefan to do it alone. So alone, that's the rate. That's my unknown, and there's together. Common denominator is going to be 24. That's 2x. That's 24. And that's 3x. Only the numerators. That's 2x plus 24 is equal to 3x. Subtract 2x and you get your answer. So working alone, it would take Stefan 24 hours to mop a warehouse. All right, 2 more. Ted can tar a roof in 10 hours. One day Stephanie helped. It took 5. How long would it take Stephanie to do it alone? All right, press pause, then press play. So alone and together, my unknown is the Stephanie alone. Common denominators would be 10x. Subtract x and you have your answer. I know I went a little fast, right? So the answer is 10, and then write a sentence. It would take Stephanie 10 hours to tar a roof alone. That would be a lonely job. 8, working together, Maria and Sumali can pick 40 bushels of apples in 6 hours. Had she done it alone, it would take, so together is 6, alone is 8, and how long would it take Maria to do it alone? So Sumali is, that's the rate, that's my unknown, and that's together. The common denominator, 2 times 4 and 2 times 3, be 2 times 4 times 3, which is 24. So we're going to multiply by 3x, by 24, and by 4x. Subtract 3x and you get your answer. So it would take Maria 24 hours to pick 40 bushels of apples alone. All right, number 9. Sarah Wong and Eugene left the White House at the same time. This is a different type of question. It's dirt. They drove in the opposite directions. That's important. Eugene drove 2 kilometers an hour slower than Sarah Wong. After 3 hours, they were 360 kilometers apart. Find Sarah Wong's speed. So let's break this down. This is going to be a little bit more challenging than the lesson, but we can do it together. So we have Sarah Wong and Eugene. And what do we know? They went in opposite. Eugene drove 2 kilometers an hour slower than Sarah Wong. So however fast Sarah Wong was going, this one was slower by 2. After left the White at the same time. So after 3 hours, they were this far apart. So both of them have traveled 3 hours. And now the end part. Now we need to have an understanding of this before we go any further. So if they go in opposite directions, right? So let's say I have the 2 distances. So Sarah went this direction and Eugene went this direction. And so we have 2 different distances, right? And so together when I add them up, the answer is 360. So when I understand this, I'm going to break it down like this. I'm going to get one distance by itself by subtracting. And so what I can do is I can call this one my unknown, and the second one is going to be 360 subtract that. So we have a distance, and then if I go 360 subtract that, it'll give me the other distance. So it's a little bit more challenging when they're going in opposite directions. So when I add these together, it'll be 360. Do you see that when I add them together, the D's would cross out and it would be 360. So when I add them together, it's 360. It's a little challenging. All right, so one equation is D equals 3x, and the second one is 360 take away D, x subtract 2 times 3. Now D is equal to 3x. So I'm going to put that in for D. And I'm going to solve for x. So I'm going to combine like terms. I'm going to add. And I'm going to add. When I divide this, I get 61 miles per hour. So the question is, what was Sarah Wong's speed? That's x, and the answer is 61 miles per hour. Put that here. Where can I write the sentence? Right here. All right. A little bit challenging. Let's do the next one. A container ship traveled to dry dock and back. It took 3 hours longer to go there than it did to come back. The average speed on the trip was 10 kilometers per hour there. The average speed on the way back was 13 kilometers. How many hours did the trip there take? So let's break this down. Distance is equal to rate times time. Our 2 categories here is the trip there and back. So it went to the dry dock. So it's really a there and back question. On the way there, the average speed there was 10 kilometers an hour. The average speed on the way back was 13. It said it took 3 hours longer to go there. So we add 3 to that on the way there. And the distance would be the same because it's there and back. So that one's a lot easier. And then we write down the 2 equations and make them equal to each other because they're both equal to D. So I'm going to distribute and make them equal. I'm going to subtract 10 and divide. So the question is, how many hours did the trip there take? So x is the trip back. So the trip there, I have to add 3 and get 13. So the trip there So the trip to the dry dock took 13 hours. All right, number 11. Maria traveled to the lake and back. So this is a lake and back or there and back kind of question. On the trip there to the lake, she traveled 25 miles per hour. On the way back, she traveled 30 miles per hour. And it says, how long did the trip there take if the return trip took 4 hours? So this took 4 hours. I don't know that, but I know the distance is the same for a there and back question. So the two equations, and then make them equal to each other. So 20x is equal to 120. Divide by 2, and you get 6. Make sure, and that's the only unknown. So the trip there, the trip to the lake took 6 hours. All right, number 12. Perry left the movie theater and drove towards the recycling plant at an average speed of 36, because that's what you do, right, after the movies, of 36 miles per hour. Sometimes later, Jessica left driving the same direction, but at an average speed of 60. After driving for 3 hours, Jessica caught up with Perry. How long did Perry drive before Jessica caught up? So, distance is equal to rate times time. We have Jessica and Perry. We know that Perry went 36 miles per hour and Jessica went 60. We know that Jessica caught up after 3 hours. So Jessica went 3 hours, and we don't know, but we know that 3 hours plus something is what Perry went, and they went the same distance. So one equation is 36 times x plus 3, and the other equation 60 times 3. We make them equal to each other. 36 times 3 is 108. 60 times 3 is 180, and then we subtract and solve it. So 180 take away 108 is 72, and then divide by, let me put it right here, divide by 36, and the answer is 2. So how long did Perry drive before Jessica caught up? And so we have to go 2 plus 3, so the answer is 5. Number 13, Cody drove to his friend's house and back. So it's there and back question again. Those are usually a lot simpler than other types of questions that could be asked. On the trip there, he drove 39 kilometers an hour, and on the return trip went 65 kilometers an hour. How long did the trip take there if the return trip took 3 hours? So set this up. So D equals 39x, D equals 65 times 3. Make them equal to each other. And then divide. If I leave it as 65 times 3, oops, I got to divide by 39. Haha. So if I leave it as 65 times 3, 3 goes into 39 13 times, and then 65 divided by 13 is 5. That's one way to simplify it without a calculator to make it easier. So that's what x is. So it says, how long did the trip there take? So the trip there took 5 hours. All right, number 14. A jet flew to Jakarta. That's a very big city in Indonesia. And back, that's in Southeast Asia. The trip there took 6 hours and the trip back. So it's there and back. The trip there took 6 hours, and the trip back took 5 hours. What was the jet's average speed on the trip there if it averaged 222 kilometers per hour back? And then I have my equation. So we have 6x. If I multiply that, that's 1,110. Kind of like an array. And then divide. And I'll do it for you. Divide by 6, it's 185. So the trip there, the jet flew at a rate of 185 kilometers per hour. Number 15. Natalie left home and drove towards her friend's house at an average speed of 80 miles per hour, 80 kilometers an hour. May left 2 hours later and drove in the opposite direction with an average speed of 40 kilometers an hour. How long does May need to drive before they're 400 kilometers apart? So this one's going to be a little trickier. We'll do it together. It's all in the setup. The equation's easy. So we have Natalie and we have May. Break down what we know. Natalie is driving at a speed of 80 kilometers an hour. That's okay. That's under 60 miles an hour. May is going 40 kilometers an hour. And May left 2 hours later. So Natalie has a head start of 2 hours. And the distances is 400. So I don't know what they are. But I know if I add them together, it's 400. So whatever the one is, I take 400 and subtract it, and that's what the other one would be if you add them together to be 400. We have two equations. So what D equals is going to go in here. And that subtract sign goes to both as I solve this. So 80x and 160 go in for D, and then distribute the negative. Combine like terms. I get 240 is equal to 120, divide, and I get the answer to be 2. Now, how long does May need to drive before they are 400 kilometers apart? And so the answer is that. It's 2. All right. 16. A cruise ship left Port 26, traveled towards Guam. That's an island in the Pacific. A submarine left 1 hour later, 2 miles per hour faster in an effort to catch up. After 10 hours, the sub did finally catch up. Find the cruise's average speed. So distance is equal to rate times time. We have a cruise ship and a submarine. And so the cruise ship has gone for 1 more hour than the sub because the cruise ship left first. The sub is going, oh, and it tells me the times too. 10 hours. So this went for 10 hours. So that means the cruise ship has gone for 11 hours because it's left, it has 1 more hour out in the water. The rate, I don't know, but I know the submarine's going 2 miles per hour faster. And because they're getting caught up with each other, the distances are the same. So one is 11 times x, the other is 10, and x plus 2, and then I'm going to solve it. So make it equal to each other, subtract 10, and then you get the answer. So the cruise ship speed was 20, what? Miles per hour. All right, turn the page. Now we'll do some mix problems. And that will end our assignment. For a mixture problem, you have 2 things you're mixing, and then you have the end mix at the end. So we're going to organize it as I read it. So the first mix is 4 liters, and it's 90% alcohol. The The second one was 8 liters, and I don't know. And then, oh, a pure water. So pure water would mean no percent of alcohol. And then the N mix, 4 plus 8 is 12, and I want to know what this N mix is then. So multiply it together. 8 times 0 is 0. 12x, divide by 12, and you get your answer. So 36 divided by 12, so that's 30. So the N mix is 30% alcohol. Think of it like a chemistry class rather than like a restaurant. 18. 5 quarts of an alcohol solution was mixed with 1 quart of 51% alcohol solution to make 31% of an alcohol. Again, think of chemistry, not like a restaurant. So we have 2 mixes, and then the N mix. Again, oh, I should have put this down, okay? It's quantity and percent, right? That's what we're looking at, quantity and percent. So how much do we have of the first one? We don't know this. The second one is 1 quart at 51%. And then the N solution, 5 plus 1 is 6. And it's 31. And what's this X? So we multiply. That's 186. Subtract 51. And you get, what, 140, 135. Divide. It goes in evenly 27 times. Again, try it yourself first, then press play. I know I'm going fast because I expect you to do it first. Press pause, try it, then press play. So we have 4 kilograms, and it's 28% peanuts. Then we have 12 kilograms. We don't know. And then we have the N mix. Oh, we do know it's 44. And then we add this together. We now have 16, and we're trying to figure that out. So multiply, that's 112. Multiply, that's 528. I'm helping you. And then 16 times X. Add this together, and it's 640. Divide by 16, and you get 40. So the new mix is 40% peanuts. Number 20. You try first. Press pause. Here we go. We have brand A, B, and the N mix. It's all in structuring it, right? So in brand A, how much of brand A? We don't know. That's 20% fruit juice to be mixed with 3 gallons of grape juice. Well, grape juice is 100% juice. To create a mix containing 40%. So if I add these together, my N mix is X plus 3. That was the tricky part. You have to add them, and now we have our equation. So that's 20X, 300, and then multiply it. That's 40X and 120, and then that's what I solve. So subtract 20, subtract 120, I think that's 180, and then that would make it 90? 9? Maybe just 9. 9. When I divide, so how much of brand A? You need 9 gallons of brand A. Alright, number 21. 3 fluid ounces of an alcohol solution was mixed with 7 of an 80% alcohol solution to make 71%. Find the percent concentration of the first solution. So we have 1, we have 2, thing 1, thing 2, and the N mix. We're going to organize this in terms of quantity and percent. So the first one we have 3, but I don't know the percent. The second one we have 7, and it's 80%. And then if I mix it together, we add, and it's 10. And the N mix is 71. So 3x plus 560, 710. Subtract 560. you get 150. Subtract 3 and you get 50. So the first mix so solution 1 is 50% alcohol. Last one, then we're done our homework. 2 milliliters of saline, saline means salt, was mixed with 5 milliliters of a 5% saline to make 15%. What's the percent concentration of the first solution? Thing 1, thing 2 is equal to the end mix. Organize this information by quantity and percent. So we have 2 milliliters, we don't know. We have 5 milliliters, 5%. And then the end mix will be 7 by adding, and then the percent at the end is 15. So we have 2x, we have 25, and 7 times 15, which is 105. Subtract 25, and I get 80. Divide by 2, and I get 40. So the first solution is 40% saline. That's it. Mr. G Math over and out. I'm proud of you for doing your work. Till next time.